Assalamualaikum and good evening. My name is Khairul Naqiuddin Rohazli. My matrix number is AE170126 and I am from Group 4. Okay, now I would like to present the FIR coding we use in this project. For the line 1, 2 and 3, it's just simple command. And for line 5, is sampling frequency and we assume as 100 samples. For line 7, this is a reading data from Excel sheet. It depends on different computer. If you save your Excel sheet in different location, coding will be different. Okay, for line 9 and 10, both is variable in the Excel sheet, which is X is data Y and Y is also data. Okay. For line 12 to 17, this command is used to plot the figure. We plot the variable x and y, and we label x as time in unit second, and we label y is amplitude in unit voltage. And the title is original signal. For line number 19, that's just a comment. For line 21 and 22, this fast Fourier transform of the signal. And lastly, for the line 24 and 35, this command is used to plot the magnitude and phase spectrum of original signal.
Hi, my name is Sin Yee. So now I will continue for the coding of FIR filter. So now as you can see in line 29, this is the coding for FIR filter, and here is the value that we assume for the FIR filter. And to get a nice filter signal, we have adjusted the cutoff frequency to be 2. Then next, we have to apply the original audio signal to the FIR design. And we name it as filter signal. Then we plot out the filter signal graph. The first figure will be filter signal which undergo the FIR filter. Then the magnitude spectrum after filtering and the phase spectrum after filtering. Finally, we run the sound coding for the filter signal, and this 44100 is the frame rate, and since the number of the signal is 88200 divided by 2 will be 44100. So now I will run the coding to listen to the filter sound. So this is the original signal and the magnitude spectrum and phase spectrum. And then this is the filter signal, and this is magnitude spectrum after filtering and phase spectrum after filtering. And this is the magnitude response for the Hamming window method of FIR. So that's all from me. I will pass to next member. Thank you.
Hi and Assalamualaikum. My name is Norashikin binti Nasaruddin. My matrix number is DE190039. I will explain the coding for IIR. First, we need to define X and S is the data signal that our lecturer give to us. Set the value of BB equal to 4, SP equal to 30, FP equal to 800, Fs equal to 100, and F equal to 500, 5000. This value can adjust to find a good result. And this is coding to filter the result of the signal. To plot the graph, we need to subplot 311 for frequency response, 312 for frequency response in dB, and 313 for phase response. And we need to click run to see the graph. And this is our result for IIR filter. This is frequency response. This is the graph for frequency response. The graph for frequency response in dB and the graph for phase response. That's all from me. Thank you.
Hi, Assalamualaikum. My name is Najmi Nazhan bin Sazuki. My metric card number is CE190055. So today I will present for the convolution technique in calculating output signal of a system. So basically, convolution is when we pass the input signal to the system. So we can categorize it as a frequency domain or time domain. So discrete time convolution is a method to finding a zero state response of relaxed linear time invariant LTI system. This convolution also to enhance based in our audio player. So the method used is a finite sum of sample of one signal. We multiply with the sample with time and delay. So here we need to use the FIR filter. We apply a convolution. So this is the coding that we use to make the process of convolution for the signal. So here we can see we declare it as yt equals to conv y multiply with x. X is the given signal. So when we multiply it, this is the result for the FIR for the convolution. So here we can see this is in the time domain. So we move to IIR filter. So this is the coding that we use. So ht is equals to conv h times s. S is also the signal given. So we just multiply it with the input here. So all we get is this signal. So that's all from me. Thank you.
Greeting, Doctor. My name is Mun Feng. Metric number is AE190088. Now I will going to present the part of the tech transform with the MATLAB software. First of all, we need to load the data from Excel file. Then this is my Excel file. Then this coding will read my Excel file through this location. Then for X, we assign that this is the data of the time. Then Y is the data of amplitude. Next, we have set the parameter, which is the sampling frequency is 100 samples. Then capital X is the FFT of Y, which is the amplitude of the signal. Then we also have assigned the F equal to linear space vectors and cutoff frequency and T. Then we have designed the elliptic filter to find the tech transform. we have to use the 6-order arithmetic analog low-pass filter with a 3 dB of ripple in the passband and the stop bands 90 dB. Then we run the code. Then after we run the coding, the tech transform will represent in the workspace here. Then is the result of the tech transform. So that's all for our group presentation. Thank you.